This will be for the Khan Academy exercise, differentiability at a point, algebraic. All right, some notes. There's basically two main steps here, but it's very tedious if you get to the second step. Anyhow, first step here, to test if the piecewise function is continuous, you want to plug in the point that is on the boundary of both functions. Okay, that point, that number is going to be given in the first sentence. If you don't get the same answer for both functions, it is not continuous at that point. Okay, if it's not continuous at that point, it is also not differentiable, and in that case, you could skip step 2. All right, so if it's not continuous, it's not going to be differentiable, and you need to get the same answer for both functions in order for it to be continuous. If it is continuous, then you move on to step 2. All right, to test if it's differentiable at a point t, use the derivative equation below. All right, you want to remember that the number is subbed in for t. So we learned this in the other exercise. This is the derivative, or f prime of t, at the point x equals t. So you're going to sub in t in the second part of the numerator and denominator. Okay, and I'll take you through that process. But for the differential part, once again, you must get the same answer for both functions in order for it to be differentiable. Okay, so it's similar to the continuous part in that you have to get the same answer. But step 2 takes a little bit longer. All right, is the function given continuous and differentiable at x equals 1? Okay, notice x equals 1 is on the boundary of both piecewise functions. So you can go by this number here or the number given in the first sentence, like I said. Okay, and these answer choices are the same for all 4 questions. Okay, it's either going to be continuous or not, or differentiable or not. Okay, but the truth of the matter is, it's never going to be answer B. Okay, the function cannot be differentiable if it is not continuous. So really, it's never going to be that case. All right, so here they're asking us if the function is continuous or differentiable at x equals 1. All right, so in order to test if it's continuous, we simply have to plug in x equals 1. You can see 1 is on the boundary of both piecewise functions. Also, it says right here, x equals 1. Okay, so for this function here, let me make some room. All right, so we're plugging in 1 in both piecewise functions. All right, right there and right there. So it's going to be 1 squared plus 2 times 1. One squared is 1. 2 times 1 is 2. And of course, 1 plus 2 is 3. In the second function, we're plugging in x equals 1 right here. It's going to be 4 times 1 minus 1. 4 times 1 is 4. Minus 1. And that one is also 3. Okay, so since 3 equals 3, the function is continuous. All right, so we got that out of the way. Now we have to move on to step 2 and see if it's differentiable. Okay, if this failed, then we could skip step 2. But since it passed, we have to move on and see if it's differentiable. All right, so we're going to be using this equation on both functions, and we're going to have to plug in that value for t. All right, so one function at a time here. So again, for g prime of x, that's going to be g of x minus g of t over x minus t. Okay, and it's really, I should have wrote in the front here, I should have wrote the limit as x approaches t. All right, so for this function here, we're going to be doing g prime of 1. Okay, remember we said that goes in place of t, not x. Even though it says x equals 1, t is the value where we're finding the derivative. We're differentiating. All right, so we're going to do g prime of 2. And that's going to equal g of x, which is this function right here, x squared plus 2x, minus g of t. So that's going to be, I'm not sure why I put in 2. I meant to say 1. All right. So g of x is x squared plus 2 minus g of t. So it's going to be minus g of 1. All right, since t equals 1. And that's going to be divided by x minus t, or x minus 1. So we have x squared plus 2x minus g of 1. Well, 1 gets plugged in here, but we already did that before. This was 1 plus 2 times 1, or 1 plus 2, which is 3. So it's minus 3. All right, because we did this before when we found out if it was continuous. And that's divided by x minus 1. All right, remember we're finding the limit now as x approaches t, which in this case is 1. Okay, now if we use direct substitution at this point, it's just going to be 0 over 0. So we have to factor this. Okay, so two numbers that multiply to negative 3 and add to positive 2. That's going to be negative 1 times positive 3. 3 times negative 1 is negative 3. 3 plus negative 1 is positive 2. We're just factoring this here. So we're going to use negative 1 and positive 3. All right, so that's going to be x minus 1 times x plus 3 divided by x minus 1. And of course, x minus 1 over x minus 1 cancels. And we're just left with x plus 3. All right, so we're trying to find the limit as x approaches 1. I know I didn't write that each time, but I wanted to save some space. We're trying to find the limit as x approaches 1 of x plus 3. And now we can use direct substitution. We can just sub in the 1 in place of x. That's just 1 plus 3, which equals 4. Okay, if we took the 1 and subbed it in here, we would have got 0 over 0. So we had to factor. Okay, now we got 4. And we have to see if we get the same answer for the other piecewise function. So I have to erase this and test the next one, okay? But we got 4 for this one. All right, now we have to do the same thing for the other function. I'll write it properly this time. We are doing the limit as x approaches t, and that's going to be f of x minus f of t over x minus t. All right, it's basically change in y over change in x. So for the second piecewise function, f of x is going to be 4x minus 1. Okay, I'm going to skip writing the limit part until the end. F of x is 4x minus 1 minus f of 1 all over x minus 1. Okay, remember t is the point where we're differentiating. Even though it said in the write-up, it said x equals 1. That's what's getting subbed in for t. All right. So we have 4x minus 1. And we did f of 1 at the beginning. When you plug in 1 here, it was 4 times 1, which is 4, minus 1, that's 3. So it's going to be minus 3 over x minus 1. Okay, and that equals 4x minus 4 over x minus 1. Okay, and if we subbed in the limit as x approaches 1, if we did it at this point, it wouldn't work. It would just be 0 over 0. So we have to factor this. Okay, so factor the numerator, the common, that's a 4. The common multiple is 4. 4x divided by 4 is just x. Negative 4 divided by 4 is negative 1. And that's divided by x minus 1. X minus 1's cancel. And we are left with 4. Okay. Normally, we would have to plug in at the end the limit as x approaches 1. But in this case, since it was just a 4, where there's nothing to plug in, so the answer is just 4. Okay, so we got 4 for the first one and 4 for the second one. All right, step 1, we got 3 equals 3. Step 2, we got 4 equals 4. So it is both continuous and differentiable. All right, here we want to solve it. Continuous and differentiable at x equals 4. All right, so let's plug it in. It's a function f. All right, so for the first one, f of 4, that's going to equal 2 times 4 plus 3. Okay, that's going to be 8 plus 3, which is 11. And for the second function, f of 4, plug in right there. It's going to be 4 squared minus 5. All right, 16 minus 5 is 11. So since 11 equals 11, the function is continuous. All right, so we got that part out of the way. All right, now the tedious part. We want to see if it's differentiable. Okay, as always, that's going to be the limit as x approaches t. F of x minus f of t over x minus t. All right, now we're evaluating at 4, so it's the limit as x approaches 4. F of x is 2x plus 3. F of t is going to be f of 4, so it's minus f of 4 divided by x minus t, but we said t is 4, so that's x minus 4. Now, I'm not going to write the limit part each time because you really don't do this until the end. All right, we have 2x plus 3 minus f of 4. Well, we already plugged in 4 in the first part. I wrote it here. F of 4 is just 11, so it's going to be minus 11 divided by x minus 4. All right, 2x plus 3 minus 11, that's going to be a negative 8 over x minus 4. 2x minus 8, the common multiple is a 2, so factor out a 2. 2x divided by 2 is x. Negative 8 divided by 2 is negative 4. Divided by x minus 4. X minus 4's cancel, and you're just left with 2. All right. If there was a variable here, you'd have to do limit as x approaches 4 and sub it in place of x, okay? But in this case, there's nothing to sub in, so it's just going to be 2. All right, so f prime of x is going to be a 2. All right, and let's see if we get 2 for the other one. All right, now the bottom function. Once again, limit as x approaches t. So let's see. We're going to 4, right? So it's the limit as x approaches 4. F of x is just x squared minus 5. F of t is going to be f of 4 divided by x minus 4. All right, we're subbing in 4 in place of t. So we have x squared minus 5. We subbed in 4 in the first part. That was 4 squared minus 5. We said that was 11. So it's going to be minus 11 divided by x minus 4. All right, negative 5. We have x squared. Negative 5 minus 11 is negative 16. That's divided by x minus 4. Okay, x squared minus 16 factors into x plus 4, x minus 4. All right, if you don't see it, imagine x squared minus 16 is the same as x squared plus 0x minus 16. Okay, so you want two numbers that multiply to negative 16 and add to 0. If you wrote out the factors for negative 16, that's just going to be negative 4 times 4. Okay, negative 4 times 4 equals negative 16. Negative 4 plus 4 is 0. So I just used negative 4 and positive 4 right here when I factored. And let me make some room. All right, so that is divided by x minus 4. And of course, x minus 4 over itself cancels. We're left with x plus 4. It's the limit as x approaches 4 of x plus 4. And if we sub in 4 in place of x, of course, that's 4 plus 4, which equals 8. Okay, what did we get last time? Last time we got 2. Okay, this time we got 8. 2 does not equal 8. Okay, so it is not differentiable. All right, you cannot find the derivative at that point. All right, so it was continuous because we got 11 equals 11, but it was not differentiable. 2 does not equal 8. All right, last one. At x equals negative 2, let's test for continuity first. Okay, so we have f, that's going to be f of negative 2. So plug in negative 2 right there. It's negative 1.5 times negative 2 squared. Okay, that's going to be negative 1.5. Negative 2 squared is 4. And that's going to equal negative 6. For this one here, plug in negative 2. That's going to be 6 times negative 2 minus 5. That's negative 12 minus 5, which is negative 17. Are these equal? No, negative 6 does not equal negative 17. Okay, so it is not continuous, and we don't have to do step 2. If it's not continuous, it's also not differentiable. Okay, so we got lucky on that one. It is neither. Remember, if it fails step 1, then you don't have to do step 2.